Okay, for the next part of our class, we're going to look at how do I estimate what the right sample size is. And we'll be relying on the work of Jacob Cohen. It's a lovely picture of the gentleman up in the top left-hand corner. And he had a real focus on statistical power and just saying, well, how do you know what size sample to use for your study? So, and we'll look at Cohen's, what's referred to as Cohen's D. I've posted an article. It's his paper on estimating effect size, and just a fairly easy way to assess what sample size you need, given for how big a difference you're expecting between, for example, two means. Your null and alternate hypothesis. Okay, Cohen's D. Okay, so we set alpha equal to 0.05, and then we go to reject the null hypothesis like we did in the previous section with respect to the z-test for the average age and also for the number of steps taken. So if we have a sense of the magnitude of the effect size, now where we get that is we get that from, that's the literature review, right? That's one of the reasons why you do the literature review. Not only do you develop an understanding of the research topic itself, but you also will now be looking at methodological issues. How do people who ran similar studies, how do they measure the constructs or concepts that are important to the study, and also what was the standard deviation for the metrics that they used? What was the sample sizes that they used? Now you should be able to assess, based on existing literature, how best to design your study, what an appropriate effect size is, how big a change do you want to see, or how big a difference do you want to see from the perspective or relative to your null hypothesis. And if you have a sense of what's an appropriate difference or a meaningful difference in terms of a minimum, then you can assess, well, what sample size do I need to give myself the best chance of rejecting the null hypothesis if indeed the alternate hypothesis is true. Not a difficult measure. So when you're going through your literature review, you'll have a sense of what the mean difference you're expecting is, say between two independent groups, or between the alternate hypothesis for a single mean z-test or t-test. And you're simply taking what your estimate of what a meaningful difference would be, dividing it by your best guess knowledge of what the standard deviation for your measure that you're going to be using for your inferential testing. Do that, just mean difference divided by the standard deviation. If d is between 0 and 0.2, you have a very small effect. Smaller the effect, the bigger the sample size you're going to need. Any d between 0.2 and say 0.8 is a medium effect. And in that case, you're going to need a medium-sized sample size. If your effect is very large, then you can have the luxury of only requiring a fairly small sample size. And we'll see what do we mean by a large sample, medium-sized sample, and a small sample. So Cohen's d itself is fairly straightforward to calculate. And as he says, the power of a statistical test is the probability that the inferential test result will lead you to correctly reject HO. If H1 is true, right? So if H1 is true, you should reject the null hypothesis, the right thing to do. That's your power. That is, power is the probability that the test will identify a treatment effect if a treatment effect truly exists, right? That's kind of like the whole reason why you're running your study. Okay. What's the driver here? In a nutshell and in a very general form, the standard deviation for your distribution of sample means is equal to your standard deviation over the square root of n, right? And we know that the standard deviation for the distribution of sample means, your standard error, as your sample size gets larger, your standard deviation gets smaller and smaller. So your standard error gets smaller and smaller as the sample size gets large. This is analogous to confidence intervals in survey design, right? Your survey design, and we actually did kind of like estimation power in survey methods, and we said, okay, if I want a sample size where I want my confidence interval to be plus or minus 5%, I want my results to be accurate to within plus or minus 5% 19 times out of 20. I need a sample size of roughly 300 and some. This is along the similar vein in terms of, in survey methods, we're doing estimation. In program evaluation work, we're doing comparisons of means, for example. We're comparing a treatment to a control. Okay, you can read the article on Cohen. It's on Blackboard. This is what we would go. So let's say I'm looking at running an independent means t-test. I am comparing the monthly cell phone bill of North Bay residents compared to Timmins residents. A $10 difference per month is meaningful to me. So if I find that North Bay spends $10 more per month on average on their cell phone bill than, say, a Timmins resident, that's pretty significant, right? So I'm looking at roughly about a 17-18% difference. Previous research, when I did my lit review, showed that the standard deviation was roughly $12.5. Okay, so what do? I run my Cohen's D. I take my difference of $10, right? MA minus MB, so let's say 70 minus 60 is 10. Divide it by my estimate of the standard deviation, which is 12.5, and I get a D of 0.8. If I look up in the table here, 0.8 is a large effect. Now, for 0.05 two-tailed, I go to table 2 in Cohen's paper, and that would say per group I would need a sample size of 26. So I would need 52 people in my study, 26 North Bay, 26 Powassan, to give me adequate statistical power. And what do I mean by adequate statistical power? The power is 0.8. So if the alternate hypothesis is true and there is that $10 difference, if I run the study 100 times, 80 out of the 100 times I would reject the null, which is the right thing to do, which is my power, 1 minus beta. 20% of the time I would fail to reject the null when I should, which would be beta. Now, in my examples from the previous section of the previous video, I was looking at like 14-20% power, which is absolutely horrible. Okay. There are tools to do sample size estimation. The one I have, you don't have to actually install it on your computer. I have it right here. So I want that t-test. I want to look at t-test, 2 independent groups. And I want to determine my inputs. So N1, N1 and N2. So a mean of 70, mean of 60, and the standard deviation within each 12.5. And I can calculate my effect size with 0.8. I can then transfer that to my window. It's kind of a funky do program. And I want my power to be 0.8 to replicate Cohen. And it's a two-tailed test with 0.05. And then I calculate. There. So there for my t-test. I could have gone with n's unequal, but they're equal, so it defaults to them being the same. The allocation ratio n2, n1. So there it is. My actual power is 0.8074. What they do is they just calculate the t distributions. I get my t critical is 2.00856. Right? That I could look that up on my t table. Let's see here, just to confirm it. My t-table, my degrees of freedom are 50. Oh, I might not have it. No, I don't. Oh, let's do it in Excel. Sorry. So I can do a t equal to t inverse two-tail. 0.05 with 50 degrees of freedom, and there's my 2.008559. They're rounded. And using these two distributions, T0 and a difference of 10 in terms of the t distributions, that calculates my beta. There's my beta is the probability of making a type 2 error. There's my 0.2, and then here's my 0.8 for my actual power. So you can use a product like this. I think it's got a whole series. I can do chi-square tests, and my HO, H1s. So I won't go through that in this case, but yeah, it's a handy little tool. You don't have to install it, but it allows you to do sample size estimation. And on your MRPs, I would work with you. Basically, when you're doing your design, you've consulted with your client, you're doing your lit review, you're coming up with your methodology. I can help you if you're doing a type of study that requires this. You know, a survey design, you would just use confidence intervals. For any kind of evaluation work, you would do this. But if you're doing chi-squares and such. Okay, this is the app that I just showed you, G-Power. The link is here on the PowerPoint. Okay. So just to kind of, this is like a small little thing. This is from Cohen from 1994. So even when used and interpreted properly with a significance criterion almost always 0.05, you set that a priori, you kind of do that before you collect your data. HO has little to commend in it in the testing of psychological theories, and its usual reject HO, confirm the theory form. The ritual dichotomous reject accept decision, however, objective and administratively convenient, is not the way any science is done. So what Cohen was saying is, rejecting the null hypothesis, it doesn't really help you if you don't have a really solid sense of, in terms of the alternate hypothesis, in terms of what is you feel important. And you really do have to focus on just flat rejecting the null and failing to reject the null blindly without looking at your design and to say, well, did my design give me a chance to reject the null if the alternate hypothesis is true? You know, how big an effect was I looking for? And based on that, knowing an estimate of the standard deviation, what sample size do I need to give myself a chance? And he gives like, in terms of the logic, if the null hypothesis is correct, then these data are highly unlikely. These data have occurred, therefore the null hypothesis is highly unlikely. And that's not true. Whether the null hypothesis and the alternate hypothesis at its core is true based on no real information at all is basically a 50-50 proposition. Right? It's just, I'm just kind of, it's either, that's the probability. Saying that the null hypothesis is highly unlikely by rejecting the null is kind of like missing the point of research, right? Research is the building of knowledge. You do it through replication. You do it through well-designed studies, so power is important. If you have good statistical power, and if there's 100 studies, 80 of them should result in rejection of the null, and you're building a body of knowledge. And the work that you're doing in your MRPs will be building upon that knowledge. And so the logic of what they're saying here, the null hypothesis is highly unlikely, well, no, that's not looking at it correctly. And it gives a more concrete example of this logic statement. And so if a person is a Canadian, then he or she is probably not an MP in our parliament. True enough. The person is an MP in our parliament. Therefore, he or she is probably not a Canadian. No, he's still a Canadian. If you reject the null hypothesis, you could be committing a type 1 error. It still could be the null hypothesis is true. So that's why kind of like just focusing on the rejecting or failing to reject the null is not really truly the best focus. The focus should be on developing good studies, having good sample sizes, building a body of knowledge through well-designed studies with adequate ends, and assessing, what your alpha truly is. We'll get into that in the following weeks. And also, what is your likelihood of rejecting the null? What is your statistical power? That's what he's getting at here. And the driver is your sample size is hugely important. Here is the same effect. So they say this is a difference of $10 between 70 and 60, or 60 and 70, 60 and 70. These are the distribution of sample means. This is for a very large N, so very large. Let's say, well, in our case, let's say it's 26 per group, and this would be maybe 5 per group, right? Small sample size, the distribution of sampling means fans out. There's more overlap between the curves, making it harder for you to reject the null if the alternate hypothesis is true. In this case, my sample size is larger. The standard deviation for the distribution of sample means is smaller because it's basically equal to your standard deviation over the square root of n, and you have a better chance of rejecting the null. Okay. As a practical example, so let's say you're doing a study, and we've had work with with boards of education before. As a research consultant for a board of education, someone comes with a proposal to complete an evaluation of the effectiveness of a new math tutorial program for grade 3 students underperforming in math. The person wants to randomly assign students to a control group and another group of subjects or students to a treatment group, right? So one group gets status quo, the other group gets, which would be the existing curriculum, and the other group gets the new math tutorial program. Have them run through this with the control group just getting the standard curriculum, and then the treatment group getting the new training program for 3 months. And at the end of 3 months, assess if there's a difference between the control and the treatment group. This is the type of thing you'll have to do if you're working in program evaluation out in your career. The person has come to you to get advice on what sample size to use. What would you do? Well, you can pause and think about it for a bit, but one thing you'll need to do is you need to do your lit review. Right? And this is why lit reviews, I keep coming back to why it's really critically important. You want to find more information because what are they doing? They're going to administer a math achievement test. So there is probably a standardized math achievement test that they're going to use. You need to find information about that test. You need the normative data. Particularly what you need is the standard deviation. And then you have to ask them, well, how much do you want to see the treatment group improve relative to the control group? Like, how much of an improvement do you want to see? And they may say, oh, we'd love to see, at the minimum, a 20% increase in performance. Right? We want the control group to do 20% better than the treatment group to do 20% better than the control group. But once you have an estimate of the size of the effect they're looking for, then you can say, okay, I know what the standard deviation from the lit review is. I know what a 20% increase is, or what a reasonable increase is, and then I go to Cohen's work and I figure out what sample size I need for my two groups. Right? That's why what we're talking about today is critically important. The next thing we're going to talk about is the opposite end of the case when we have big data and big numbers.